All right, last question from the 2005 test. Now, that 2004 test, I talked about how the last question sometimes is the most difficult. Well, I wouldn't say that's the case necessarily here. This is a pretty straightforward array, one-dimensional ints. So the first one, we're going to take an average. I guess the trick is it's not all of the ints in the array. It's just a subset that runs from first to last inclusive. So we'll make a index for loop that will run from first to last. Pretty easy to write a while loop as well. And then we'll write a has improved method where we're going to start and see if each score is greater than or equal to the previous value. Now that's their claim. So instead of trying to necessarily verify that claim, I'm actually going to look for a counter case to it. If I can find one case where the successive value is not greater than or equal to, meaning less than, then I'll just immediately return false. If I work my way across the entire array and I never encounter that, then I'll say true. And then finally, if they did improve, then they get to only compute their average from like the back half of their scores, so which would be the higher ones because they've improved. So unless I guess they're all the same. And every time it seems like there's a question like this, somebody wants to argue, well, what if it's the middle value? Does that count, or is it even or odd? It doesn't matter. It just tells us right here, index is greater than or equal to scores dot length over 2. So we're just going to write code that translates that exactly, and that's going to be in part C. All right, so 3 straightforward methods to write. We have a 1D array called scores. We want to get an average. So, whenever you're doing an average, just, I guess, be a little bit careful that you're actually doing math that involves a double. So where you'd have to be careful here is if, these are int values in the array. So if you made an int total, could potentially end up dividing by 2 ints at the end. So let's see what happens here if we start with an int total. We'll put it to 0. Again, we're not going to write a loop that's going to go all the way across, right? Why would we start our loop at 0? Let's start our loop at first. Okay, and let's run it up to and inclusive of. I think that's important. I bet some of us might forget to put that equals there if we're not careful, up to last. Okay, so they did say inclusive, so we want to include all those values. And then simply take total and add to the existing total whatever the scores array holds for us at index I. All right, so how do we turn this into an average? Well, an average is just a total divided by how many scores you just looked at. Well, okay, how many scores did we just look at? Well, let's see, is it, the length of the array? No, because we did a subset of it. Is it last minus first? Not exactly. We've had this discussion before. So if you do last minus first, let's say your teacher says do problems 1 through 10 tonight. If you did 10 minus 1, you'd think, oh, I only have 9 homework problems. Well, no, if you're doing problems 1 through 10, that's actually 10 questions. So it's last minus first plus 1 when you're talking inclusive. Now, right now, I've got all ints across the board. First, last, total, they're all ints. I got to sneak a double in here somewhere. I could cast total to double. I could redeclare it as a double. I could even just do something kind of sneaky, like put 1.0 that introduces a double to the denominator. But somewhere, you've got to put a double in there. Okay, so right now, I do have a double before the division takes place. I should get a true average. Okay, those scores look like they check out. All right, so has improved. All right, this time I do want to walk across the entire array. I'm not going to use an enhanced loop because I want to look at a value and a value next to it. So I really kind of benefit from having those indexes. If I wrote a traditional loop that went all the way across the scores array from 0 to length, potentially I'm going to go out of bounds depending on how I write my next steps. So I might come back and change that in a minute. All right, now if I'm looking at the scores, maybe I want to say, I compared to I plus 1. Maybe you want to look at I minus 1 compared to I don't know. It's up to you. So if you were going to write code like this where you're looking at I compared to I minus 1, then you're going to want to start your loop at 1. Now their claim is that these scores follow this type of pattern. They're saying that the score on the right is always greater than or equal to the score on the left. So what I had mentioned earlier is we're going to look for the exact opposite of that. If we can find one single violation where that's false, then we can immediately return false. We don't need to look at any other scores. We're done. We know this thing is not that of an improved student. If we can walk across this entire array and never find a violation, then we're willing to say true. This student did improve over the back half of their scores. Okay, so my 3 Part B test cases appear to check out. Okay, and finally in Part C, the final average. This is a problem where if we do not invoke our methods properly from A and B, we're not going to get full credit. So this is like that methods and control structures idea that the College Board's big on, and that they've told us that our question too is going to be based on this. They want to see you call user declared methods. So they know that you know about string class methods. They know you know about array list methods because your teachers taught them to you. Can you call user declared methods and get them to work properly? If they need parameters, can you give them to them? So we've got an average method that wants 2 ints. Okay, we've got a has improved method that doesn't want any. The has improved method returns a Boolean. So we could use that Boolean as the basis of an if statement. Okay, this is a Boolean. This is going to say true or it's going to say false. If it says true, I need to return an average that only is calculated from the back half of the array. This average method gives me a double, provided that I give it 2 ints. This method wants a double. So I will use my average method, but I have to give it 2 ints. So I'm going to give it scores dot length divided by 2, and I'm going to give it scores dot length. Now, if you're looking at that, I could really see us messing this up if we're not careful. I specifically do not want a 2.0 there. And if you're thinking, well, wait, then you're dividing by ints. Yeah, but remember, this thing only takes ints. You put 2.0 in there, now you got a double. So you're going to get a violation. How come I didn't put scores.length minus 1? Well, actually, I should have, okay? Because if you remember, the way that we wrote our method in Part A was we made it an inclusive method. So, for example, let's say there's 10 scores in this array. They're going to be indexed 0 to 9. My code right now would be sending 10 from here, okay, back up to the top. And that 10 would then become an inclusive index, and I would go out of bounds. Okay, so we got to put a -1 here so that our inclusive method from Part A receives the proper closing index. This is not substring. This isn't like we can just put one number in there. Okay, we want to divide by 2. We want to keep this at the int level. We got to put a -1 here so that we stay in bounds in Part A. All right, if this is not the case, okay, then we're going to do pretty much the same exact thing, okay, except now we're going to start this at 0. So I could see like another way to do this. You could make maybe like an int from index and then use your if else to, or just an if statement to potentially change it. So maybe say like int from is 0, and then you have an if statement that looks to like change the from index, and then you return based off that. But yeah, let's see what happens here. Now, what you absolutely don't want to do is you don't want to recreate any code from A or B. If you start recreating the has improved method, if you wrote your own code here to calculate an average, it doesn't matter if you're getting the right answers. So you could be looking at this going, oh, I got all the right answers. Well, if you wrote a loop in this problem, you're not going to get full credit. Okay, so there's absolutely no reason to write a loop in Part C if you're properly invoking the methods from A and B. That's a very, very important lesson to remember. Okay, and if you didn't know that, now you do.